to the Data Science Interview Prep podcast, where we discuss topics commonly asked about in data science interviews, and we give a high-level overview on those subjects. So today we'll be discussing cross-validation, a key technique in machine learning. All right, so let's dive right in. Cross-validation is a method used to evaluate the performance of a machine learning model. This process involves dividing a data set up into training, validation, and testing sets to fit and tune the parameters of a machine learning model. Specifically, a validation set is a chunk of data that gets split to tune the hyperparameters of a model. For example, let's say or imagine a neural network. In this case, these might be the learning rate, the number of hidden units, or the number of layers that we want to tune and find the best optimization for. Basically, we use the validation set to evaluate the performance of different model parameter combinations, and then we select the best performing one. The test set is going to be a separate set of data that is used to evaluate the final model, model after the hyperparameters have been chosen. And you might be wondering, if we have a validation set, then why do we use the test set? Well, the test set helps us to estimate the generalization error of our selected model. That's a little bit confusing maybe, but in simpler terms, the test set gives us an idea of how well our model performs on new or unseen data. Okay, so to sum it up, the validation set is used to choose the best model and the model parameters, while the test set is used to evaluate that chosen model. One thing to note is that it's critical that you keep the test set separate from the training data and the validation data. Why is it so important to keep your test set apart from everything else? Well, it's so that the model doesn't get a chance to learn from the test set or cheat by using it to make decisions about the hyperparameters. All right, so there are several different types of cross-validation, but the most common is what's known as the k-fold cross-validation. In k-fold cross-validation, the dataset is divided into equal-sized folds, with the number of folds being equal to the value of k. So if you have k equals 5, you're going to have 5 folds. The model is then trained and evaluated k times, with a different fold being used as the test set each time. To get an idea of how well the model has done, the performance of the model is then averaged across the k iterations. Great. So now we know how to do cross-validation, but let's take a look again at why it's important in machine learning. Well, one reason is that it allows us to get a more accurate estimate of the model's performance. When we train and test a model on the same data, we run the risk of overfitting. By using cross-validation, we can address this issue as it helps us to get a better sense of how the model will perform on new data. On another note, this method is also really useful for model selection. When machine learning practitioners are trying to choose between different models or hyperparameter settings, it can be really helpful to use cross-validation as a way to compare the performance of these different models and select the best one. Finally, cross-validation can help us to identify and diagnose problems with our model. So let's say, for example, if the model is performing poorly on the test set, we can use cross-validation to try and understand why and to identify potential issues with either the model itself or the input data. Okay, so that's a brief overview of cross-validation and why it's an important technique in machine learning. Thanks for tuning in to today's episode of the Data Science Interview Prep podcast. We hope you found this episode on cross-validation helpful and informative. Be sure to join us next week where we'll discuss other interesting topics in the field of data science.